which is created by the sun. On those rare occasions when the moon, earth, and the sun are all lined up just right, the moon passes through this shadow. This would happen every full moon if the moon orbited around this earth in the same plane as the earth orbits around the sun. The moon's orbit, however, is tilted about 5 degrees above the Earth-Sun plane. This tilt itself, however, rotates, allowing eclipses to happen when the tilt of this plane lines up with the Earth-Sun plane, blocking sunlight. An eclipse of the moon can only take place at full moon, and only if the moon passes through some portion of the Earth's shadow. The shadow is actually composed of 2 cone-shaped components, one inside the other. The outer or penumbral shadow is a zone where some portion of the sun's rays are blocked. In contrast, the inner or umbral shadow is a region devoid of all direct sunlight. A lunar eclipse is visible over an entire hemisphere and is seen at the same time to everyone who is in sight of the full moon. Because of local time zones, however, the times of a lunar eclipse can span many hours. Lunar eclipses can last for more than 3 hours because the moon and the earth are moving slowly in relation to each other, and the shadow cast by the earth is so large. Because of their sizes and the relative distances between the earth, moon, and sun, this shadow is much larger than that cast by the moon on the earth during a solar eclipse. Although eclipses are always caused by the same general lineup of sun, moon, and earth, each lunar eclipse may have its own unique visual characteristic. Colors and the deepness of the shadow on the surface are affected by the type of eclipse, local weather conditions, atmospheric conditions, and the geographic location of the observer. When the moon is in the darkest part of the Earth's shadow, or in totality, it can have some beautiful colors, usually a dark pastel, such as violet or a very dark apricot. The 3 types of eclipses are a partial lunar eclipse, where a portion of the moon passes through the Earth's umbral shadow. These events are easy to see even with the unaided eye. 2. A penumbral lunar eclipse, where the moon passes through the Earth's penumbral shadow. These events are subtle and quite difficult, if not impossible, to observe. During a penumbral eclipse, the moon's light is dimmed but does not go dark due to the fact that the penumbral shadow is not dark enough to black out the sun's light. A penumbral eclipse is sometimes referred to as an oppulse eclipse. And 3. A total lunar eclipse, where the moon passes through the Earth's umbral shadow. During the time of totality, the moon's color may change to a dull copper tone, an effect caused by earth shine or reflected earth light. eclipses. L values for various luminosities are defined in the following table. L value 0, color very dark, moon almost invisible at darkness with no features. L value 1, color gray or brownish, dark shadows with a few features faintly visible. L value 2, color rusty brown or dark red, umbra very dark in the center and light at the edges. L value 3, color reddish to brick red, edges of umbra are light in color and may appear yellow. L value 4, color orange or copper, very bright umbra trim and may appear bluish in color. The Earth's shadow has darker and lighter areas, which you can see watching an animated GIF. As the moon passes through the Earth's shadow, you can see the moon's face get darker and darker as the shadow crosses its face until the moon is almost completely dark. Even when the moon is in the darkest area of the Earth's shadow, though there is still some light on the moon's surface. This is caused by the fact light from the sun bends slightly as it hits the Earth's atmosphere. This fact, along with the fact that light always bends around things it hits, casts a faint light on the moon. When the moon is in the darkest part of the Earth's shadow, or in totality, it can have some beautiful colors, usually a dark pastel, such as violet or a very dark apricot. The best advice I can give for photographing a lunar eclipse is to take as many pictures as you can at many different exposure times and f-stop settings. Most of these photographs will probably not turn out as you hoped or expected. The bottom line is that eclipse photography is an exercise in patience. As it is with most photography, you must take many shots to get one or two that are good. Hence, if you have a point-and-shoot camera with a zoom lens, zoom the lens out as far as you can get to get the highest possible magnification. The minimum focal length for getting a good-looking moon is about 300 millimeters. Photographing an eclipse may require exposure times 4 to 1,000 times longer as compared to recording a moon at normal. Short exposures are useful only during the partial stages near the beginning and end of the eclipse. It would be safe to try every camera setting you've got. There's plenty of time to experiment during this leisurely event. Lunar and solar eclipse facts. Full moons are the only time lunar eclipses occur. New moons are the only time solar eclipses occur. A solar eclipse occurs 2 weeks after or 2 weeks before a total lunar eclipse. Lunar eclipses can last for a maximum of 3 hours and 40 minutes, with the period of totality lasting for as long as 1 hour and 40 minutes. Solar eclipses can last for a maximum of 7 minutes and 40 seconds if they are total at the equator, 12 minutes and 24 seconds at most if they are annular. Lunar eclipses can never happen more than 3 times a year. Solar eclipses happen at least twice a year, but never more than 5 times a year. Lunar eclipses are visible over an entire hemisphere. Solar eclipses are visible and lunar eclipses go together in pairs. A solar eclipse is always followed